Hello, Mindsetters. Today we're doing a revision of your trigonometry, but we only focusing on our 2Ds and 3Ds problems, okay? But there's a lot of things that I need you guys to make sure that you know before you go on to your exam, right? So I'm looking at the exam type questions, but under 2Ds and 3Ds, okay? Now, the first thing that you need to make sure is that you are able to use the sine rule and cosine rule to find the length of an unknown side or the size of an unknown angle, right? Now remember the sine rule, the cosine rule, and also the area rule, right? So now we have the following questions, all right? These are your exam questions. Now, guys, just to remind you, with your 2Ds and 3Ds, your solution to triangles, if you've got two sides and two angles and maybe looking for one unknown, you can use your sine rule. And now remember your sine rule, you will have sine A divided by A equals to sine B divided by B equals to sine C divided by C, or vice versa. And with your cosine rule, you must have two sides and an included angle and looking for the other side. Okay, now just to tackle these questions, guys, so I've got the first question. It says, a piece of land has the form of a quadrilateral ABCD. Let's just look at that. So we've got A, B, C, and D, all right? Now, with AB equal to 20, they've given that in the diagram. BC is 12. CD is 7. It's there in our diagram. And then AD is 28, so it's given. And the angle ABC, now remember guys, the one in the middle is the angle that we're looking for, that we're given here. So it says the angle ABC is 110 degrees, okay? So we can just put it there. So this is 110, okay? So this is 110. Now, calculate the length of the fence AC correct to one decimal place. Now, guys, we need to make sure we have the following. Now, watch, we've got this side, which is 12 meters. We've got 20 and the included angle. Now, remember the rule that we're going to apply here, because we've got two sides and an included angle, and we're looking for the other side. It's the cosine rule. Now, let me just remind you how to, it is there in your formula sheet. So it says, if I have A squared, it will be equals to B squared plus C squared minus 2BC cos of A. Now remember, this is from your triangle, any triangle ABC, all right? So now, A is the unknown side, okay? So in this case, it will be your AC. So now I'm looking for AC, so I will say this is AC squared equals to the side that is given, I'll call it B, so 12 and 20. So I've got 12 squared plus 20 squared minus, okay? Now, minus 2 times 12 by 20 cos of the included angle, guys. The included angle here is 110, all right? So it's 110. Now, if we look at this, guys, we have covered everything, so we substituted. The only unknown will be your AC, okay? So now we continue. You can just put this in your calculator. So AC will be, now remember at the end of the day, we'll square root whatever we have here. So I can just put this in our calculator, all right? So your calculator will read, we have, that is 12 squared, which is 144, okay, plus 20 squared, 400, right, minus, just get the calculator away. So you have 24 by 20, 24 by 20, right, and cos of 110 and that is 26,61. Okay? Now, we have 26,6. Now, let's just check. They're saying to 1 decimal place. Okay, so it's 26, just confirm there. 26,61, all right? So now, and we need to check the units. Okay, we're looking for the side, so that will be in meters. So it's 26,6 meters. So we have that side, which is AC. So that is 26,6 meters, right? So we have answered the first question. Now we move on to the next question. They're saying now, calculate the size of angle BAC correct to the nearest degree. Now we know that this is 26,6, right? We're looking for BAC, so this is the angle that we want to calculate, okay? Now, we know that this is 110 degrees, it's given. Now guys, watch. We have a side, okay? A side. Now I'm looking for this angle here, okay? So this angle is opposite that side, okay? And then I've got that angle opposite this side. So I can use a sine rule here, okay? The sine rule, so we'll have sine of 110 divided by the side, which is 26,6, equals to sine of the angle that we're looking for, which is BAC, all divided by the side, in this case, is 12, all right? Now, guys, remember, I've got fractions now. I need to make that sine BAC the subject of the formula. So I can cross multiply or just multiply by 12 throughout. So in other words, I will have 12 by sine 110 divided by 26,6 equals to sine of BAC. All right? Now, I want BAC. BAC will be equal to, now I've worked it out on my calculator, and then to get the sine, now I'm looking for the angle. I've got sine there, so I'm going to say arc sine of whatever I get on my left-hand side. So let's do that. Okay. So I will have, in this case, so we're saying arc sine of fraction 12 by sine 10, no, sine 110, okay, and then we have 26,6. Right, so we get 25,08, and then they asked us to round it off to the nearest degree. So we get 25 degrees. Okay. Now we move on to the next question, guys. Now remember, this is just revision of your grade 11, okay? So your sine rule, cosine rule, and your error rule. So now we want to calculate, let's go back. This was 26,6, and this is 110, okay? And what else have we worked it out? So we said this is 25 degrees. Okay, now they're asking us to find angle D now. They're asking us to find D. Where is D? So there is D. Now, what do I have in this triangle? I know that if I have a side, and a side, and looking for the included angle, that will be our cosine rule. Now remember, we have a squared equals to b squared plus c squared minus 2bc cos of a. And in this case, the side that's opposite the angle will be your 26,6, and then you square that equals to the other two sides, that's 7 and 28, so 7 squared plus 28 squared minus 2 times those two sides, which is 7 by 28, cos of the angle that we're looking for, so cos of d. Now guys, watch, we have one unknown here. Now to to make cos the subject of the formula, so I need to transpose that. So I need to get that to the left-hand side and divide by negative 14 times 28. And now I have cos the subject. Okay. Now, so this is what we're going to have. We've got, now we're saying bracket 26,6 squared minus. Now remember, the reason why I'm saying minus, because the 7 squared is positive on the right hand side. So it's minus 7 squared, which is 49, minus 28 squared. All right. Now we get our answer there. Okay. So now that answer that we have on our right hand side is negative 3136 divided by 25. Then we have to divide that answer by negative 14 by 28. Okay. So now this is what we get, 0.32. So in other words, we have 0.32 equals to cos D. Now, cos D is a subject of the formula, but we want to work out what D is. So it's now easy again. So we're going to say shift cos of 0.32. Okay, so this is our answer. Okay, so you're going to say now shift cos of our answer equals to, so we get 71.33. Okay, so to the nearest degree, it's going to be 71 degrees. Okay, right. Now, guys, we're done with that. We move on to the next question. So let's just put in what we have. We've got 71 there. We've got 26,6. We have 110. And here, if I'm not mistaken, there was 25 degrees. Now, let's look at the next question. It says, calculate the area of the entire piece of land, okay, which is ABCD. Now, we look at ABCD. If we look at this shape, the whole of that shape, we're not sure whether it's a square, whatever, and stuff. We don't know this shape. We don't have a formula for this shape. But what we do know is that ABC is a triangle, okay? And then ACD is also a triangle. So we know the formula to work out the area of a triangle, okay? So now we're going to say the area of ABCD, it's equals to half, okay? Now remember the area rule, say area equals to half AB sine of C. So I have 71, so I'm going to use this one first. So times by the 7 times by the 28 sine of 71, and then plus. Now half of that top triangle, 12 by 20, all right, by sine of 110, okay, right? And then now we just put this in the calculator. All right, so we have, this is half 7 times 28, which is 14 by 7. So 14 by 7 sine of 71. We get that. Sorry, plus, now this is half of 12 by 20, so that is 6 by 20 times sine of 110. We get 205,42 to correct one decimal place, so 205.4. So our 205.4. Now, guys, now because we're dealing with meters and we're now working with area, so this is square meters. Okay, Right, so we're done with that question. We know that it's your sine rule, cosine rule, and area rule that we have applied there. Okay. Now, guys, moving on to the next question. Okay, this looks more like a 3D, but it's not. Okay. All right. Now, we're given a diagram here, and we need to prove that AB will be K sine alpha divided by sine theta, sine alpha plus theta, or plus beta. Now, remember when you're tackling these questions, it's wise to draw diagrams and put in whatever is given and move from the known to the unknown. So in this case, I can move from this triangle to that triangle AB, with AB, which is ABC. Okay, so we want to work out that. Our solution is given, so we need to get it with theta, K, alpha, and beta. All right, so now, the first thing is to work out this side, okay? Now, how can I work out that side AB? I've got a triangle, a right angle triangle, ADC. And in this case, this will be my Y, and this is your R. So we look for a trig ratio that we can use there with R and Y. So that will be your sine. Or you can just use the sine rule there, okay? Right? So I will have sine of theta equals to K divided by that AC. And therefore, AC is K divided by sine theta. Okay, now making AC the subject. So I've got AC, which is K over sine theta. So this is K over sine theta. I need to come to this side now. And I have to remind myself, okay, if I've got two sides, two angles, and maybe missing one, then I can use the sine rule. Now, watch, this is a side that I'm looking for, and there is an angle opposite that. And then I have this side now, opposite that angle, which I don't know at the moment, but it's easy to find that because I have a triangle ABC, and some angles of a triangle add up to 180. So in other words, to work that one quicker, B is 180 degrees minus alpha plus beta. Okay, right, because what we've done here is we said beta plus alpha plus the B equals to 180 degrees, some angles of a triangle. Now, what we can do is now say AB divided by sine of the angle that is opposite AB, which is alpha, equals to, what else is known here? It's K divided by sine theta. So K divided by sine theta, divide by sine of the angle, so sine of 180 degrees, let me just write it here, minus alpha plus beta. Okay, right, so now we move on. Let's simplify that. We've got AB, so AB divided by sine alpha equals to K divided by sine of theta, divide by, now we have sine 180 degrees minus. Now remember your basic trigonometry. If I've got sine 180 minus, that is my second quadrant. And how is sine in the second quadrant? Sine is positive in the second quadrant. Okay, so we get sine of alpha plus beta. Okay, so this is all over 1. Now next, I've got AB divided by sine alpha equals to K over sine theta times now 1 over sine alpha plus beta. Okay, now guys, we need to make AB the subject of the formula now. So we say therefore, now I've got AB divided by sine alpha. The undo of division is multiplication, so I can multiply by sine alpha on both sides. So I get AB is K times 1, which is K sine alpha, all divided by sine theta times sine alpha plus beta. This was a nice one because they've given us that we need to prove that AB is K sine alpha divided by sine theta times sine alpha plus beta. Okay, that question is answered. Okay, right, guys, thank you very much. I think I should give you a short break so you quickly go get some tea and cakes, and then we see you after the break. Welcome back, guys. We continue. We've got question 3 now. Let's read. In the diagram below, MT is a vertical structure. Let's look at that MT. Okay, so we've got MT. MT is a vertical structure. P, Q, and T are the 3 points in the same horizontal plane. Okay, the angle of elevation of M from Q is theta. Okay, we see that one. And PQ is K meters. See? Okay, PQ is K meters. And PM equals to 2PQ. So PM will be 2PQ, but we know that PQ is K, so this will be 2K. All right? Now, in the area of triangle, MPQ is 2K squared sine theta times cos theta. Okay? Right? So they've given us the area. Now, the first question says, prove that MPQ, so here there should be a cap, so MPQ equals to 2 theta. So using the given information, all right, so they've given us the area. Let's write the formula for the area. We've got MPQ, so we're going to say, and the angle that we're looking for is P. So we know that area of triangle MPQ, it's equals to half, right? It's a half 2K, all right, we need that angle. So it's going to be 2K times that other side, sine of that angle that we're looking for, so which is MPQ. So we've got MPQ there. But the nice thing about this question is that they've given us the area. So they're saying the area is 2K squared sine theta cos theta. So the area is given, which is 2K squared sine theta cos theta equals to, now we've got that half 2K times K sine MPQ. So the 2 divides the 2. So we've got K by K, which gives us K squared, sine of MPQ. Okay? But at the end of the day, we want to make the MPQ the subject of the formula, right? So if I want to make that the subject, so I can now divide by K squared on both sides. Okay? Now, I've got the K squared divides the K. So in my right-hand side, I've got sine MPQ. Okay? And then your left-hand side, the K squared divides the K squared. So I've got 2 sine theta cos theta. Now, you go back. You've got your notes, your double angle identities. Remember, if you're given sine 2 theta, that will be your 2 sine theta cos theta. And if you're given cos 2 theta, that will be your cos squared theta minus sine squared theta, or 2 cos squared theta minus 1, or 1 minus 2 sine squared theta. But now, this is 2 sine theta cos theta. This is a double angle identity, so we can quickly change that to sine 2 theta equals to, now, sine of MPQ, okay? Right now, remember, if I've got K squared equals to 4 squared, then K is 4. Or if you have 2 to x equals to 2 to 7, you're solving for x, the bases are the same, so x is 7. So now I've got sine on the left-hand side, and I've got sine on the right-hand side, so therefore 2 theta is MPQ. So you have proved that MPQ is 2 theta. That's what they were looking for. Okay? Right? Now, question 3 continues. Now, hence, prove that MQ, now we need the length MQ to show that it is k square root of 1 plus 8 sine squared theta. Now we need to see where that MQ is, okay? So MQ is this side, okay? Now what do we have? We know that this is 2 theta, all right? And we know that this is 2k. We need to work out what MQ is, all right? Now remember, if I've got two sides and the included angle and looking for the other side, that is cosine rule, all right? So now, with the cosine rule, so I've got MQ squared will be equals to the other two sides. That will be your k squared plus your 2k all squared minus 2 times the first side, which is k. The next side will be your 2k cos of 2 theta, because the included angle is 2 theta here, all right? So now I need to have MQ as a subject, okay? Let's proceed and simplify. So I've got k squared plus, now the 2k by 2k, we get 4k squared, minus the 2 by 2, that's 4k by k, it's k squared. Now, to this part, I've got cos 2 theta. Like we've been saying, if I have sine 2 theta, we know it's going to be 2 sine theta cos theta. And then this will be your cos squared theta minus sine squared theta. But I'm guided by my final solution there that it's got sine squared theta. There's no cos there. So I'm going to ignore the first one, which is cos squared theta minus sine squared theta. Ignore the second one, which is 2 cos squared theta minus 1. And use the 1 minus 2 sine squared theta. So I can change that to 1 minus 2 sine squared theta. All right? Now, let's proceed with our simplification. So I get, now this is 5k squared, these two are like terms. And then distributive law, multiply into that bracket, so I get minus 4k squared. And then this is plus 8k squared sine squared theta. So I have MQ squared there. So MQ squared. Now we've got like terms again here. These two guys. 5k squared minus 4k squared. We get 1k squared. So I've got k squared plus 8k squared sine squared theta. Now remember these two. This is a term on its own. This is a term as well. And they're separated by an operation sign plus, so we can take out a common factor, which in this case is k squared. I've got k squared before the operation sign and after the operation sign. So I've got MQ squared equals to common factor k squared, bracket, I'm now left with the 1 plus 8 sine squared theta. Okay, guys, don't panic, we're getting there. Right, now, so we need to make the MQ the subject of the formula, but I have a square here. Now, to remove that square, I need to square root on both sides. So if I square root the MQ squared, so I get MQ equals to the square root of k squared is k, right? This is a term, so the square root of that I don't have, so it's 1 plus 8 sine squared theta. So your final answer stays as that, and that is what they were looking for here, that you need to prove that MQ is k square root of 1 plus 8 sine squared theta. Okay, so that answers that questions, and I hope you guys are still following. Okay, now we move on to the next question. Question 4. Now, there's too much English here, right? So question 4, a flagpole AE, right? Let's go look for that AE. Okay, we can have, we see that. That is your AE, all right? Of length 5 meters. They're giving us that the length of AE is 5. So that's 5 meters, right? Is leaning at 10 degrees to vertical AB, all right? So there is vertical AB, and then we've got 10 degrees there, and drawn parallel to AB, right, and meet CA at F. Now, saying, okay, this EF, ne, is parallel to your AB. So in other words, we know that this angle here, it will be 10 degrees. And because it forms a Z shape, remember in grade 8, you alternate angles, okay? So, and here we know that this vertical, so you can work out this angle here. If that is 10, so this is 80 degrees, okay? Now, let's proceed. Now, an observer at C, right, notes that the angle of elevation of E, the top of the flag pole, is 25 degrees. Right, so this guy is standing here and he's looking up there. So the angle of elevation will be your 25 degrees. So you've got 25 degrees there, right? While another observer at D, oh, there's too many observers. So there's this guy here at D now, observer number 2, in the same horizontal plane, finds that the angle of elevation of E is 35. Okay, so now he's looking up there and finds that this is 35 degrees. Okay, now let's just simplify that. This is your 3D. Okay, this is 90 degrees there. So if that is 90, this is 35. So it means that that angle is 55 to make it 180. Okay, now show that the distance for C to F, now is C to F, okay, this is C to F there, is 11 meters rounded off to the nearest whole number. Okay, so now we need to work from the given to the unknown. So it's in this triangle, the CF is in triangle CFE, okay? But here we can easily find EF, okay? Because we have the R, we need to work out the Y, and we've got the angle there, okay? So we can use sine. So we'll say sine of 80 degrees equals to, now sine of 80 equals to EF, not EFF. So it's EF all divided by 5, okay? Therefore, EF would be 5 times sine of 80, which gives us that EF. Now we take our calculators. So 5 times sine of 80, that gives us 4,92, all right? So EF will be 4.92, all right? So you've got EF, 4.92, right? Now, we need to work out this side. We have the angle here. We have that side now. So we've got Y and X and the angle, all right? So now, the trig ratio that deals with Y and X is tan. So it's easy now to work that one out. So we're going to say tan of 25 degrees equals to Y in this case is that EF 4,92 divide by CF, the one that we're looking for, and we need to make CF the subject of a formula, so we times by CF on both sides, and then now we'll have CF times the tan 25 equals to 4,92. Then the undo of multiplication is division, so we'll have CF equals to 4,92 divided by tan 25 equals to, now we now say 4,92 divided by tan 25 gives us 10.55. And now we go back 10.55 to the nearest whole number. So this is approximately 10.55. So rounding off to the nearest whole number, this is approximately 11, and it's in meters. So it's 11 meters. So you have proved that CF, okay, the distance CF is roughly 11. Okay. So we now have 11 there. Okay, we move on. The next question. Calculate the distance between the two observers at C and D, rounding off to the nearest whole. Okay? Now, so we need to work out this part. Okay, but what do we have? We have CF. Can we find FD? If we are able to find a FD, then we'll have two sides and an included angle, okay? So what do we have? We know that EF, let's see, EF is 4,92, right? So we have this, and do we have the angle? Yes, we've got 35, and then we're looking for this, and the angle at the top is 55. So we're looking for one unknown there. So what we can do is to now say, okay, let's quickly erase that. Now, guys, we need to work out DF. So I'm going to say DF divide by sine of. Now, what's the angle opposite DF? It's 55. So it's sine 55 equals to. Now, we have 4,92 and the 35. So you've got 4,92 divided by sine 35. And guys, here it's very important. You can tell that this is sine rule, but you have to make sure if you started with the side, divide by sine of the angle, on your right hand side you must do the same. You must not say sine now over the side. Okay, so now I have to make DF the subject, so DF will be 4,92 times sine 55 divided by sine of 35. Okay, so therefore now DF will be, let's work it out quickly, right, 4,92 times the sine of 55 divided by sine of 35. That gives us 7,02. It's now time to take a break. After the break, we'll continue with these questions. Welcome back, grade 12s. We're now looking at question 5. Let's read question 5. Refer to the figure below, which represents the Pythagorean theorem, okay, with squares drawn on the three sides of a right-angled triangle ABC. So you've got triangle ABC. Now let's see where that is. Okay, ABC. This is our triangle here. Okay, triangle ABC, and around that we have squares. This is the first square, second one, and the third one. Okay. Now, if these are squares, so in other words, it means that we have C here. Okay. So sides are the same. So here we've got A, right? And in this square, we've got B, B, B. Okay, right? We're just analyzing the information that's given to us, right? The angle CBA equals to theta. CBA, this is the angle they're talking about, right? Now, a rubber band D, okay? So there's a rubber band D, E, so it goes around there, F, G, H, K, right? So it covers the whole area. So we've got the G, H, K, D, E, and F. So you've got a rubber band around that, is stretched around this figure, okay? Now, first question, we need to write sine theta and cos theta in terms of A, B, and C, okay? Now, we need to look where is our theta. Okay, theta is here. We've got A, B, and C. In this diagram, we can work out what sine is. So you've got sine theta will be, your opposite will be your B, and then your hypotenuse is C. So that will be B divided by C. And then our cos theta will be, now the adjacent, which is A, divided by our hypotenuse will be C. Okay, so we've got that 2 marks there. Now we need to write down, without reasons, the size of GBH and KAD in terms of theta. Now GBH, so GBH, so you need to work out that. All right, now we know that we have a square there with sides C, and a square, there is 90 degrees there. And then we've got a square again here, there is also 90. We want to work out what B is in terms of theta. Now there's angles around the point, that's a revolution, okay? So we now can say this angle B plus the 90 plus the 90 plus theta equals to 360 revolution. Okay, so we've got GBH plus the 90 plus that other 90 plus the theta equals to 360 degrees, okay? Now, they said we don't have to give reasons, but then it's angles around the point. Now, therefore, GBH will be, now let's simplify, we get 360 minus 180, which gives us 180 degrees, minus the theta. So, GBH is 180 degrees minus theta. Now let's look for the other one that they're asking, which is KAD. So KAD, so they're looking for this angle, all right? Now, what do we have? We know that this is a square, so there should be 90 degrees, interior angles there, 90 degrees. Do we know this? No, we don't know yet. But what we know is that there's theta, there's 90. To complete that triangle, we can work out that angle, and it's 180 degrees minus those interior angles. So here we get 90 degrees minus theta as that angle. Now, to complete that, we have 90 plus 90 minus theta plus 90. That gives us 270 degrees minus theta. So we've got 270 degrees minus theta, right? Plus that angle that we're looking for, which is A, KAD, equals to 360. So therefore, KAD is 360 minus 270, that's 90. Transpose the theta, you get a plus theta. So KAD is 90 degrees plus theta, okay? And your GBH is 180 degrees minus theta. Now, the next question, which is your last question, it says, using your answers from 5.1 and 5.2 above, show that the area of the whole region enclosed by the rubber band is 2 bracket AB plus C squared. Now, there's quite a lot of working that we need to do here, okay? Now, what we can do is, we look at all these shapes, okay? I've got a triangle, so I'll say this is triangle 1, and then this is triangle 2, that's triangle 3, and that's triangle 4, okay? So I've got 4 triangles, okay? We know that the area of a triangle, okay, this middle one, the right angle triangle is half base times height, and these 2, because it's not right angle triangle, it's half AB sine of C, remember, from your area rule. And now I have these 3 squares, Okay, so I've got square number 1, so I'll call this, this is figure number 5, then that's figure number 6, figure number 7. Now, guys, what we need to do here is to work out all those areas, combine them, then we find the total area of that area covered by the rubber band. Okay. Now, let's look at the first area. Area number 1, which is triangle 1. So we're going to have the area total, so the total area covered will be equals to half. Right, the triangle number 1, there's A and C, not African National Congress, so it's A times C sine of the included angle, which was your GBH. We've got 180 degrees minus theta, 180 degrees minus theta, plus triangle number 2 is this one with the sides C and B, so it's going to be half, okay, it's going to be half BC, so we've got BC sine of the included angle, which is 90 degrees plus theta, plus the third figure is a triangle again, which is a right angle triangle, so it's going to be a half, the base will be your A, and the height will be your B. So AB plus figure number 4. Figure 4 is a triangle again, so it's half, base is B, height is A. So half B times A plus, now the remaining figures, remember, it will be your squares. So square 1, it will be A by A, square 2, C by C, and then square 3 will be B by B. Okay, so we've got A squared plus the B squared plus the C squared. So this is a square which has got A times A, and then the other one is B times B, then the other one is C times C. Now let's simplify. Okay, now looking at this first part, we've got sine 180 degrees minus theta. 180 minus is the second quadrant and sine is positive, so we get half AC sine of theta plus, here we have 90 degrees plus is the second quadrant, sine is positive, but because of 90 sine changes to cos, so I get half BC cos of theta plus, now these two are like terms, we've got half AB plus half AB, so we get 1AB plus the A squared plus B squared plus C squared. All right, now guys, we're getting there. Now they said use the information above to solve this problem. Okay, the first info, what they've asked us to do is to work out what sine is, right? We did that. Sine theta is B divided by C, and cos theta is A divided by C, so we can substitute there. So we've got half AC times the sine is B divided by C, B divided by C, plus half BC times the cos. Cos is A divided by C. So we've got cos is A divided by C plus the AB plus. Now, guys, very important here. Let's look at this piece. This is a triangle, a right angle triangle. I've got A here, I've got B here, and then C. And using Pythagoras, we know that A squared plus B squared equals to C squared. So in other words, where I see A squared plus B squared, that gives us C squared. So that will be your C squared plus that C squared. Now, simplify further. You get half the C divides the C, so I'm left with the AB, plus the C divides by the C, so it's half AB, plus the AB, plus, now these two are like terms, so this is 2C squared. Okay? Now, we have, now half AB plus half AB, we get AB. plus that AB plus the 2C squared. Now, these two guys are like terms, okay? Now, the 1AB plus the 1AB, we get 2AB plus the 2C squared, okay? Now, as we've been saying, we've got an operation sign between the terms, which is a plus, and I've got two terms, so I can take out the common factor of 2 bracket AB plus C squared. So, in other words, we have now proved that using all that information that was given to you, the area that is covered by the rubber band using those triangles and also the squares is given by 2 bracket AB plus C squared. Okay, guys, thank you very much for listening. Make sure that you go back and do these questions on your own without looking at my solutions, and see you next time. Peace.